Claisen ester condensation. When two ester molecules condense together to form beta keto ester, then the reaction is called as Claisen ester condensation. So here we have two molecules of the ester and you are reacting it with a base, and the product that is obtained here is beta keto ester, where you can see that the ester group and as well as the keto group are in beta position with respect to each other. Here, the base that you use for abstracting the alpha hydrogen should be exactly the same as the leaving group that is present in the ester. Because the base that you use can also undergo nucleophilic addition elimination reaction where it forms the tetrahedral intermediate and thrusts the leaving group out. This may sometimes replace the leaving group that is present in the initial ester. Like what we have seen in the case of aldol addition reaction, here again, one carbonyl compound is going to act as a nucleophile and the other carbonyl compound is going to act as an electrophile. In the product, this is one ester molecule, and this part right here is coming from the other ester molecule. And there is a new carbon-carbon single bond that is formed between the carbonyl carbon of one ester molecule and the alpha carbon of the other ester molecule. Here is the mechanism for the Claisen ester condensation. First, to begin with, the methoxide ion, which is the base, is going to go grab the alpha hydrogen. So here is our alpha hydrogen. This alpha hydrogen will be abstracted by the base. And it's going to thrust those electrons onto carbon to form the enolate ion. This would be our enolate ion. And in the next step, this enolate ion is going to make a nucleophilic attack on the carbonyl carbon of the other ester molecule. So let's draw the structure of the other ester molecule, where this is going to go and make a nucleophilic attack on this carbonyl carbon, thrusting those electrons onto oxygen to form the tetrahedral intermediate. Once this tetrahedral intermediate is formed, since it is not stable, it is going to collapse, for which these electrons are going to come here to form the carbon-oxygen double bond. And since there is a leaving group here, this is going to take its electrons and leave. This will give us a final product, which is the beta keto ester. Here is our ester functional group, and here is a keto group. So this is the new carbon-carbon bond that is formed. And you can also look into the reaction here, where you can see that the base that is used for the synthesis is exactly the same as the leaving group that is present in the reaction. Okay. So if you switch this, then probably you will be getting a mixture of different beta keto esters. So in Claisen condensation, two ester molecules will react where one is going to act as a nucleophile. So this one right here is acting as a nucleophile, and the other one is going to act as an electrophile. Right? And in the final product, you can see those two parts. So this is one of the ester molecules, and this part right here is coming from the other ester molecule.